Hello again, class. Today we're going to get into writing the equation that represents a line. Before we begin, I'd like you to do a little exercise here. I would like you to try to come up with what's the most important information about a line. Now, to do this, I would like you to try to envision a situation where you're trying to describe this line to a friend that can't see the line. And you're going to want to try to get your friend to draw the same exact line without telling them exact coordinate points. You want to do like the least amount of information, just the most important stuff. So I'd like you to pause the video and I'd like you to try to come up with two things that you could tell your friend that would allow them to draw this line exactly how you see it. Okay, so something that you might have said was a starting point, right? Where do I start this line? And that's true with a lot of things. Like, where do you begin is a good place to start. When we're talking about mathematics, that place where we start is known as the y-intercept. Now, we have a fancy way of writing y-intercept in math, just so you don't have to write out y-intercept every time, just a little notation. And that fancy way is with a b. So b is the y-intercept. And the y-intercept is exactly what it seems like. Intercept, when you're talking about football, means to cross the path of the football and take it away from your opponent, right? So when we're talking about the y-intercept, we are talking about where our line crosses the y-axis. So for this situation here, where would this line begin? Where would it start? And that's going to be a value of 0. So the y value for a y-intercept is 0, crosses the line at 0. And the other important information that you might have come up with was, where does this line go? What is it doing? Is it going up? Is it going down? How fast is it going up? How fast is it going down? If you told your friend that it was just going down, well, I could have drawn a line like this. That line is going down, but it doesn't convey the same information as our original line. So we want to be able to tell exactly how this line is changing. And from our previous lessons, we know how we do that by indicating the slope of the line. So we can say the slope, and just like y-intercept, the slope of a line in mathematics has a special notation. We call that m, and that stands for slope. And the slope is also known as the rate of change. How much is the item changing in the situation? All right, so those are the two most important things. And with those two things, you can graph any situation, and you can also write the equation of any linear situation. So for this situation, our rise over our run, if we look from any point to another point, so let's go from here to here, we're rising a -4 value, and we're running over 2. And that simplifies to a slope of -2. So our slope is -2. Now, we need a way to put these together. And the way that we put these together to make nice mathematical sense is with an equation. So this equation that we use in algebra is known as slope-intercept form. And the way that it looks is y equals mx plus b. This is the most common form of an equation that you're going to see because it's one of the easiest formulas to work with. So all you have to do, once you know the slope and the y-intercept, you just take this structure and you plug your values in. So we just take our slope, which was -2, so y equals -2. The x just stays x. That's a variable that's changing. Those represent our coordinate points. And then the b we said was 0, so I would do plus 0, which, I mean, we don't even have to do. When you add 0 to something, it doesn't change it. Right? So this is the equation that represents our line. If we take a look at another situation, we're given the graph of a line and we want to write the equation. What is the equation that represents this situation? And remember, the equation has to represent all of our coordinate points. It has to work for all of our coordinate points. So all we have to do is we have to use slope-intercept form. Y equals mx plus b. So we have to find the slope in this situation, and we have to find the y-intercept in this situation. And then we have our equation. Our starting point and our rate of change, our slope, will allow us to create an equation. That simply. Nice, easy shortcut for all of you shortcut seekers. So the y-intercept, pretty easy to find. The y-intercept is where our line crosses the y-axis. We commonly refer this to the starting point. So the y-intercept here is at 3. And it's a positive 3. Our slope for this situation, our m, is going to be calculated. We have to figure that out. So you did that in previous units. Go from any one point to another point. In this situation, we rise 1, positive 1, and run positive 2. So our slope is 1 over 2. So our equation that represents this situation all together is going to be y equals 1 over 2x plus 3. And previously in this unit, you checked to see if a point was on a line. You could do that with every single one of these points. You could check with all of these points, and every single one of those points will work in this new equation that we just created. It will satisfy the equation. All right, here we go. Now I would like you to write the equation on your own. So you can pause the video now and try it all on your own, or you could continue to walk through the problem with me. So go ahead, pause it, or continue if you're a little bit more, if you're a little bit confused and need a little bit more guided practice. So when we're trying to write the equation of a line, we should automatically be thinking y equals mx plus b. And that's slope-intercept form. What you have to remember about slope-intercept form is we need a slope and a y-intercept. If you're still a little confused about slope and y-intercept, if you look at an M looks like hills. And if you think about hills, when you're walking up and down hills, hills have slopes. So that's how you could remember which one is slope and which one is y-intercept. And the B, I kind of remember that the B is almost an upside down Y. So if you kind of just flip it around here, and it's almost like an upside down Y. So the B, y-intercept, the slope is the M. So I'd like you to go ahead and find what is the B in this situation. Find me what is the B in this situation. And the B is going to be 5 for this situation. The slope in the situation, count from any one point to the next point. Slope is a positive 3. This line is going up from left to right, so that should be a positive value. And now put your equation together. So put your B and your M into your equation, and you'll have your final product. So y equals mx plus b. That is the equation that represents this line. Okay, here we go. Pause the video. Do this one all by yourself. Okay, hopefully you got it. Let's check your answer and our equation. Always think linear equation. Y equals mx plus b. Slope-intercept form. The y-intercept in this situation, where does the line begin, is -2. The slope of this situation, the rise over run, we are going to rise a -1. and we're going to run positive 3. So that's negative 1 over 3. If you went in a different direction, if I rose 1 and ran a negative 3, remember that's the same exact fraction. A positive divided by a negative is the same thing as a negative divided by a positive. So either way you look at it, you have a negative 1 over 3 for our slope. And now we put those together to make our equation. Y equals negative 1 over 3x minus 2. Finished equation. Okay, here we go. To sum up what we've learned in this lesson, we've learned that there is a shortcut formula that we can use to create the equation of any linear situation. And that shortcut form is slope-intercept form. Slope-intercept form. It has what is contained in the equation in the name. You have to have the slope and you have to have the y-intercept to create slope-intercept form. So that form that we need to memorize, you have to have it memorized for the end of course test, is y equals mx plus b. And the m is the slope, the b is the y-intercept. If you have a hard time remembering what slope is, remember slope is what you have on hills. Hills have slope, and that m looks like it's hit a set of hills. And the b kind of looks like an upside down y, so the b is the y-intercept.